Yeah, hi guys. So here's a quick outline of my presentation. I'm going to start off with my motivation, and then get down into some of the technical challenges in order to do real-time control of ROSCon, and then I'll show some videos of actual demonstrations. So starting off with motivation, we had a project going with Woodside Energy, which is Australia's largest oil and gas producer. And one of the things they want to use robots for is these offshore drilling platforms. They want to deploy a robot there to do basic maintenance. And that could save them a lot of money because right now they fly a technician in by helicopter, to turn a couple valves or something like that. So a lot of the tasks that they need to do require fairly high contact forces. We're talking about like maybe 5 to 10 kilograms, or like 40 newtons, I guess. So that hasn't been done too much with ROS1 in the past. We need to be able to react to those contact forces. The tasks we're talking about here are like high voltage switching or taking electrical measurements and basic things like opening doors and turning valves. So I looked for a previous solution which I could use for this. About the best example I could find came from the DARPA Robotics Challenge. And you can see that this is a little bit hackish. They made it work, but there's not a lot of friction in the valve, so it seems like maybe not so realistic. And they aren't gripping it and turning it in really a natural way. So I wanted to try to make something better. So my solution is called the MultiArm package. And it works, it's robot agnostic. It works with any numbers of degrees of freedom, any number of joints. On the left is an example of an SI5, 7 degree of freedom. In the center is a UR3, 6 degree of freedom. And on the right, we have a heavy series elastic actuator, which is 6 degrees of freedom. And it works with all those robots because it uses ROS control. Oh, and this jogger is Jacobian based. So there were quite a few challenges to overcome here. Making something real time with ROS1 is difficult. I needed to handle singularities, be robust to signal noise. In case it was teleoperated, the operator might have a little jitter. We want to reduce jerk to the actuators and so on. We also needed to support multiple manipulators because our robot has 2 arms. And finally, we want to make this safe. So the way I achieved a deterministic control rate was with this multi-threaded architecture. It's called master-slave architecture. Basically, there's one master thread which handles the ROS interface. It takes incoming commands at an uncertain rate because with ROS1, we're never sure when a message is going to arrive or even if it is going to arrive. And that shares, the master thread shares that data with a collision checking thread and a jog calculations thread. So those are, the heavier computations are done in those threads. And then the master thread ensures that the commands get republished at a constant rate, whatever rate you desire. So for me, it was 250 hertz, which is fairly fast. A problem here is if there was a long delay in incoming commands, your arm might continue moving. So for safety's sake, there's a timeout in the master thread. The next challenge was singularity handling. So on the left is a video of Universal Robot's built-in software. It actually doesn't handle singularities at all. So this video shows it jogging into singularity and then becoming locked there and actually triggering a fault. On the right is the MultiArm package, which actually looks ahead for upcoming singularities and slows down as it approaches. And that's a pretty good way to handle it. It gives the operator some good visual feedback when he's getting close to singularity. And we found it's really intuitive. So you can set that threshold with a ROS parameter to be as safe or as conservative as you wish. So another challenge is signal filtering, particularly when you're teleoperating a robot. There may be a lot of noise. You want to filter out that noise. So I used a first order filter, which is really computationally efficient, and it doesn't overshoot. That's also good for actuator longevity because you want to minimize jerk to the actuators. So I just want to thank Sansone, who was one particular GitHub user who contributed to this, but several other people have as well. And the graphs at the bottom just show the filter working as it should. so higher input signals are being attenuated. So like I said, our robot has 2 arms. We need to be able to jog multiple manipulators simultaneously. The really simple way to do that is to use a namespace. And you can use any number of arms with that, only limited by how many CPU threads you have. Typically, each arm takes about 20% load. So you could run quite a few arms on one thread. I just want to mention that this probably won't work for large industrial robots because they have stricter signal filtering requirements. They often require a jerk-limited trajectory or even a continuous jerk trajectory. So if you have a really large robot like that, you're going to have to look at a better filtering option like Reflexis, which is owned by Google now, or TrackPose, which is a Picnic Robotics product. So now we'll get into the good stuff, some videos about actual uses of this. Oh, and let me just mention the package is part of MoveIt now, so you can get it here. And there's a fairly easy tutorial to follow to get you started. So the 2 videos here are more current work that our lab has been doing for this oil and gas project. The upper left one shows what's called a double block and bleed. So if you have a pipeline, you need to shut off a valve at one end, shut off a valve at another end, and then open a valve in the middle to bleed it. And we're using a HTC Vive VR controller to send these jog commands to the robot. It's fairly intuitive. And the video on the lower right might not look like much until you take a closer look. What's going on there is we've put an admittance controller on top of the jogger. So it's not lined up very well with the handle initially, but when it closes, it senses the contact forces with the handle and aligns itself and centers itself on the handle. So that's really great when you're working in uncertain environments. Maybe you have some sensor noise or your camera isn't calibrated correctly or something like that. In that type of environment, you really need admittance or compliance or something along those lines. So this is a couple of videos that other people around the world have sent of themselves using the jogger. These are from the University of Canterbury. So Stephen Sue is writing with a haptic pen. You can see the robot in the background tracing his motions. And then Edward is controlling UR5 intuitively with a VR tracker, very similar to what we did at our lab. I think the reason these VR applications are so popular is there's a good Python library that makes it pretty easy to get started. And the UR arms tend to be very tolerant of sending motion commands in many different formats and not, well, they're just very tolerant of different motion commands. So the last thing I have here is a video of opening a door, and certain parts of this task are done with the jogger, certain parts are done with point-to-point regular MoveIt motions. But I'd be happy to take any questions while this plays in the background.
Thank you. Yeah, go ahead, Dave, just get to the mic.
Has this been used by anyone famous, Andy?
There's a rumor that Jeff Bezos used it at Amazon conference. It was forked by Shadow Robotics, but we aren't 100% sure, but it sure looked like he did.
I feel like that was a leading question, Dave. All right, Aish.
Hi, yeah. I happen to have one of those giant industrial robots. I was actually the one who nagged you about this not working.
I remember, yep.
Yeah, but people typically remember me for nagging. But what would it take to get this to work on one of those robots that requires jerk-limited inputs? Because it would be really nice to be able to do this stuff with actual, dangerous ones.
Yeah, I agree with you. I think the only thing holding us back from doing that is better signal filtering, which is a tough problem, but I think I mentioned 2 packages that probably could do that. Okay. Reflexis and track joint.
All right, so you want to interpose them between your package, or with the output of your package and the robots? Or the other way around?
So to interface with my package, I guess would be a little work. You would have to dive into the source code. But that would be a good improvement I could make, yeah.
Thanks.
Thanks.
All right, we're out of time, so thank you. We'll take the rest of the questions offline.